Alright, here are some solutions to the first group quiz. Problem number 1. If f of x equals 4 to the power log base 5 of x cubed, find the inverse function f inverse of x. Okay, well the first step is to replace f of x by y. So I get y equals 4 to the power log base 5 of x cubed. And now we have to solve for x. And so the first thing we want to peel off of the right side here is this 4. And the way we deal with a base of 4 is to take the log base 4 of each side. Now if you really want to, you can take the natural log of each side too. That'll work out in the end. Okay, but this is kind of the nicer way to do it. Alright, and then the log base 4 cancels this base of 4, and we're just going to be left with that exponent. So let me write that out. Log base 4 of y equals log base 5 of x cubed. And now I need to cancel the log base 5 on the right side, and the way I do that is to raise 5 to the power of each side. So 5 to the log base 4 of y equals 5 to the log base 5 of x cubed. And this time that cancels to give us 5 to the power log base 4 of y equals x cubed. And last but not least, we can take the cube root of each side. So cube root of 5 to the log base 4 of y equals x. And well, now we're supposed to let's just switch sides for a moment and bring the x over on the left side. X is the cube root of 5 to the log base 4y. Okay, now we're supposed to switch the variables. So replace all the x's by y and all the y's by x. So we get y equals cube root of 5 to the power log base 4 of y. And that's the answer. So just write it in a different form. Replace the y by f inverse of x. And that is the cube root of 5 to the log base 4 of y. Alright, now some of you might have brought this 3 out in front of the log before you found the inverse. That's totally fine. Your answer might look a little different, but it's probably equivalent to this one. And alright, so there's some variations on how to solve that, but this is one answer that would work out. Put a nice box around it. Okay, problem number 2. If f of x equals log base 5 of x plus x squared, find the derivative of the inverse of f evaluated at 26. Well, first thing to remember is this nice formula that the derivative of the inverse is almost the reciprocal of the derivative of the original function, but it's not evaluated at x, it's evaluated at y. In other words, at f inverse of x. Okay, so that's the formula to use, and let me just copy it down, but using 26 for our x value. There we go. And now f inverse of 26, for that you want to ask yourself, what do I have to plug in for x to get 26 out of it, right? So you're trying to solve the equation 26 equals log base 5 of x plus x squared. And we don't really have any methods for sort of systematically solving that for x, but you can just plug in some numbers and hope to get lucky. And let's see, 5 squared is 25, and log base 5 of 5 is 1. So 5 works out, right? So this f inverse of 26 is 5. All right. So this is equal to 1 over f prime of 5. And to evaluate that, we have to know what the derivative of f is. So f prime of x, the derivative of the logarithm is, well, almost 1 over x, and then we need this factor of 1 over natural log 5 in there, according to the rule. And derivative of x squared is 2x. So we have that, and then f prime of 5 is, well, let me let me bring this x in front of the natural log. It's 1 over 5 ln 5 plus, and 2 times 5 is 10. And coming back to our overall thing we're trying to compute here, we just wanted the reciprocal of that, right? So 1 over 5 ln 5 plus 10 is our answer. And of course you could add the fractions downstairs and then take the reciprocal, but I won't require that for full credit. Okay. All right. Number 3, compute some limits. Justify your answers. So first of all, we want to say as x goes to 2 from the left, we got to build this thing up from the inside out. So first we'll say what happens to x minus 2, and then we'll say what happens to 5 over x minus 2, and then we'll say what happens to the whole function e to the 5 over x minus 2. Okay. All right, first of all, if x is approaching 2 from the left, that means x is like 1.999. Then x minus 2 is going to be just a tiny bit smaller than 0. Right, so that's going to approach 0 from the left. And then if we do 5 divided by that, right, 5 divided by, let's say, negative 0.0001, it's going to be, you know, I forget how many zeros I said, but like 50,000, right? It's going to be really, or excuse me, negative 50,000, a really negative number, okay? So 5 over a very small negative number is a really big negative number. This is approaching negative infinity. And then e, the limit of e to the x as sort of the exponent goes to negative infinity is 0, right? And it approaches it from the positive side, from the right, but we don't need to put that in our final answer. Okay, so this limit is equal to 0. And then for the next one, x is approaching pi over 2, and I didn't say it's from the left or the right, and the reason is it doesn't matter. Okay, this is actually a it's not just a left-handed limit or just a right-handed limit, it's an overall limit. And so let's see how that plays out here. We'll say as x goes to pi over 2, we got to build up this function from the inside out. So the first thing you would do is sine x, and then you would do 1 minus sine x, and then you would do log base 3 of that. Okay, so when x goes to pi over, you got to remember what the graph of sine looks like. Okay, so it's going to be something like that, right, where pi over 2 is right here. And so the idea is as you sort of follow the graph approaching pi over 2 from either side, you're going to approach the same y value of 1. And moreover, you're approaching it from numbers that are smaller than 1, right? And so in terms of the y variable, you're approaching 1 from the left, okay, from smaller numbers than 1. So sine x is approaching 1 from the left. And all right, so it's like 0.999, right? And 1 minus 0.999 is something very close to 0, but positive, okay? And then, okay, we have the thing inside of a log approaching 0 from the right. And we know that the limit of a log as you approach 0 from the right is negative infinity. And if you forgot that rule, just think about the graph of a log function, something like this, where the negative y-axis is an asymptote. And so as you follow the graph with sort of the thing inside with the x approaching 0 from the right, then the y-coordinate approaches negative infinity. So there's your answer for that one. Okay, so this is equal to negative infinity. Number 4, just a little bit of practice with log rules. The funny thing about this one is it's not log base 4 of 48 is not nice, right? 48 is not a sort of integral power of 4, but if we use a log rule, we can rewrite this as log base 4 of 48 over 3, and 48 over 3 just happens to be 16. What a coincidence. So, and then log base 4 of 16, that's asking you which power of 4 is equal to 16, and the answer is 2. And for B, there are a whole bunch of different ways to do this one, but one way would be to, well, you could bring the 4 out in front of this natural log. Okay, so things are shrinking again. 4 times natural log of 125. And then here you have, this is square root of 5 is 5 to the 1/2, so you could bring that 1/2 out in front as well. Okay. And then the next step, well, you could either say 125 is 5 cubed, so you could bring a 3 out front and just cancel the ln 5s. Or if you want to, practice your change of base formula, you could realize that, okay, well, first of all, 4 over 1/2 is 4 times 2, so that's 8. And then ln 125 over ln 5 is, by the change of base formula, log base 5 of 125. And that log is 3. So this is 8 times 3, which is 24. One way or another, you should come out with 24 at the end. Okay. Now let's do some derivatives. For part A here, we have well, a composition of functions, right? We have this inside function cos x inside of the function 3 to the x. And so first of all, we do the derivative of 3 to the circle, right? If I circled that, and that is just itself times a sort of fudge factor of ln 3. Now somebody asked me, what's a fudge factor? I don't know if that's not really a technical term. It's just sort of something that you have to add into an equation to make it right, okay? Like usually a constant. And so I just mean to say that it's something we have to add in to make it right when the base is something other than e, right? Okay, so that's the derivative of the outside function evaluated the inside, and now we're supposed to multiply that by the derivative of the inside. The derivative of cosine is negative sine x. So that's the answer, and you can't really make that much nicer. I'll just leave it like that. You can bring the minus sign out front if you really want to. Okay, part B, f of x equals a product of 2 log functions. Now we don't have any nice rules for simplifying such a thing, and so we just need to use the product rule, okay, deal with them separately. So product rule says copy this thing twice with a plus sign in the middle. And then in one of them, you got to take the derivative of the first one. And in the other one, you got to take the derivative of the second one. So derivative of log base 3 of x is, well, natural log would be just 1 over x. We need a natural log of 3 in the denominator to get the right thing. And then that's just times log base 4 of x. And we have plus log base 3 of x from up here. And derivative of log base 4 of x is 1 over natural log 4 times 1 over x. Okay, so maybe I should simplify that a little bit. I have a 1 over x in both terms, so I could, I guess I'll factor that out. And then in the first term, what's left is log base 4x over ln 3, and in the second term, log base 3x over ln 4. Okay, good enough. Last but not least, for the derivatives, sine x to the sine x. Now, this is not something we can just use the chain rule for, because we have a variable in the base and in the exponent. Okay, it's kind of like when I asked you to do x to the x in class. And so what we need for this is logarithmic differentiation. And let's see, what are the steps for that? First of all, we replace f of x by y, so y equals sine x to the sine x. Then it's called logarithmic differentiation, so we should take the log of each side. All right, and then the purpose of that is to help us get this exponent with its variable out of the exponent and out in front here. So we get, just simplifying, we get ln y equals sine x times natural log of sine x. And now we take the derivative of each side with respect to x. So on the left side, we need to do implicit differentiation, which is going to be Derivative of natural log is 1 over y times the derivative of the inside, which is y prime. And on the right, how much of a mess is this going to be? Let's see. So it's a product, so we need to do product rule. So it would be cosine of x times ln sine of x plus sine of x times the derivative of ln sine of x. And that's a composition, so I need the chain rule. And so it's going to be 1 over the inside, which conveniently enough is sine x, times the derivative of the inside, which is cos x. So we get some cancellation there. And we get that, well, let me multiply both sides by y so I can solve for y prime. And then I have a cosine x in both terms. Let's factor that out. And then what's left? Just natural log sine x plus, and the second term just has a 1 left because I factored out the cos x. So that's basically the answer, but we should, to finish things off, we should get the entire right-hand side in terms of just x. So I'm going to replace y by what it's equal to. And if you like, you can write f prime of x instead of y prime. Doesn't matter all that much. So we get sine x to the sine x times cosine x times natural log of sine x plus 1. There we go. Okay. And finally, an integral. And the first thing I think when I look at this one is that the derivative of tan is secant squared. And so if I let u be something down here, maybe the whole denominator, then the du will make that secant squared appear. Okay, so let's try u substitution here. U equals, whoops, the denominator 1 plus 3 tan x. Excuse me, and then du is the derivative of that, which is just 0 plus 3 secant squared x dx. And in my integral I have is just the secant squared x dx, so let me divide both sides by 3. You realize that this is what we call an abuse of notation, the du over 3, right? I should probably be writing 1 over 3 times du, but we know what we mean by that, so you can use it as a sort of shorthand or abbreviation. All right, let's rewrite this thing in terms of u. The secant squared x dx becomes du over 3, so put the du there, and let me pull the 1/3 outside. And then the denominator is u, right? So so what's left inside is 1 over u. All right, now let's actually take that integral. Integral of 1 over u is, well, it's natural log u, but remember the better answer with the full domain is natural log absolute value of u, so that's what you should be writing, plus an arbitrary constant. And for our final answer, let's get it back in terms of x. Replace the u by what we defined it to be. So we get 1/3 natural log absolute value 1 plus 3 tan x plus a constant. All right. Well, I hope that group quiz was a good learning experience for you all. I will grade them and get them back to you on Monday and enter the scores on WebAssign. Have a good weekend. See you Monday.